Hi, I'm Dave Worrall. Some of you may recognize me. I've been around for a few years, working on various technologies within quantum. And I'm here to talk about industrializing quantum. Because it's good. We can go around, we can look at all these great stands, we have all this quantum technology, but what are we doing with it? Are we solving problems with it? What problems are we solving? What can we do today to solve the problems? And one of the things we look at, obviously, is cryptography, cybersecurity, cryptography, and what do we need to do about it? So one of the problems we have with RNG and QRNG is the usual thing is it ready? What are you giving me that I don't already have? There are a number of issues with QRNG. We've always had an issue of scalability. I go into meetings, I speak to people, and we used to say to them, yes, and I can give you almost a megabit. And they look at me and, no, it's not going to work. So we need scalability. We need to be able to generate gigabits, not megabits, and it needs to be good quality entropy. We need resilience. You go to a cybersecurity firm and you speak to any large organization about their cybersecurity, and they have certain boxes that need to be ticked. The devices need to scale. They need resilience. It's no good having a cryptographic system if the first thing that breaks takes your system offline. It needs to run 24/7. You need redundancy. Yeah, and if you go around these companies and you speak to them about their cybersecurity infrastructure, what they all tell you is it's all about the monitoring, reporting of these devices. You wouldn't buy a firewall, stick it in the corner and never bother looking at it again. Yeah, you monitor these things, you have a look at them, you make sure you know what's going on. This is the key to cybersecurity. Everybody knows this. You walk into a cybersecurity security operations center, what are you going to see? Hundreds of monitors with graphs telling them exactly what is going on in their networks. Where the traffic going? Where's it being diverted? What threats are they currently seeing? What's happening on the networks? They need to know this. So when we talk about industrializing QRNG, yes, we have some excellent technology and we know how to do it, but until we can meet the basic requirements for a device that people can buy and can use and meets these, we're really not meeting a need of the business at all. What we're doing them is showing them a technology which looks very, very good that they can't use. So that's what Quaid is doing. And we've built a device, we've taken some quantum technology, we've server mounted it, it's fully scalable. We start at 400 megabit per second, we scale up to multi-gigabits, and it's in a standard server 1U, 2U, 4U configuration. So you can take it, you can plug it in. And of course, that gives companies the ability to use it. But it needs to be underpinned by well-defined technology and metrology. So it needs to be understood how these devices are working. And that is one of the key things which guys have come to see as we've been talking about the metrology behind the chips, behind the circuits, how it works, what the quantum effect is, and how we're using it. And that is key. But you are still going to come up to the thing of what problem are you solving? I have entropy today. What's different? Why is your random number better than my random number? That's the wrong question. The question is, what's wrong with my entropy system today? And what's wrong with your entropy system is you don't know what it's doing. It sits there and you say, yeah, my little piece of software is running. Well, what's it doing? You know, is it running as well today as it did yesterday, as it did 6 months ago? You know, in cybersecurity, you wouldn't leave your firewall in a dark corner and leave it alone for 2 years. You constantly monitor it, you check it, you patch it, you make sure it works correctly. And that is where we're going with the Quaid. We're giving the dashboard and the tools for organizations to be able to bring entropy generation and management out of the dark corners. Turn a spotlight on it. Really give customers something they don't have. The ability to manage their entropy. The ability to look at it and to say, what I'm using today is as good as yesterday. And this test 5 years ago by the company that created it, is it still working in 5 years? I mean, not many people are still running the same computer they had 5 years ago. It just wouldn't work. Yeah? And these are the things, as we talk about industrializing quantum, it's not just about how much better we can make the quantum, how much more we understand the quantum. It's how do we solve the business problem. And that really, really is the massive thing we've been concentrating on. Because people say, you can't get traction because they turn around and tell you, well, I have an entropy source. You can when you start explaining to them the need to monitor and report is built into everything a cyber organization does. And that's the business need we need to be fulfilling. We need to be able to give them something that's not only better in its actual output, but it's also more manageable, more flexible, and much, much better at telling them when there's an issue. It's no good finding out there's an issue with the entropy when it's on CNN and Fox News, although you'd probably get two different stories anyway. But this is where we're doing. People say, can you get traction? Can you get in the marketplace? Well, working with a US company called Introspect, they've developed a product called SmokeNet. It's private VPN. The back end is powered by our entropy to ensure that it's quantum proof. We're using quantum entropy to drive this, to make the VPN completely randomized ports throughout. And this is being deployed now. Yeah. So yes, there are people out there who know how to use this. They understand the value of being able to manage and monitor and work with this equipment. Now, on top of that, there's also the ability to use this entropy for science and for many other uses. Yeah. And this is what we need to look at is not just the cryptography, not just the post-quantum encryption. It's current day standards, it's current day technologies, and how we can make it better. That's what Quaid stands for. Now, one of the companies we've been working with, Rahul is from, is a company called SECQAI. And they look at proactive AI management of cybersecurity systems. Yeah? And using the quantum entropy from our device, they are developing systems that allow people to have a proper view of their complete infrastructure. And I will hand over to Rahul just to give you a few words on SECQAI and their things.
Perfect. Thanks, Dave. Can you all hear me? Yeah, great. So we are SECQAI. We're a cybersecurity startup. And like Dave was saying, it's all about taking quantum technologies to enhance existing ones, but also looking at where it can be applied for in an organization. So our vision is to take quantum products that are out there today and integrate it into existing solutions, enhancing existing solutions. Because when we've spoken to businesses, the key thing for them is, how do we take this technology? How do we integrate it in what we have today? So some of the things that we're working on is looking at access management, a key area. We've looked at all of these different solutions that exist in the marketplace that are using passwordless technology or kind of persistent token-based technology. And what we're trying to do is look at, okay, how do we take quantum entropy sources and how do we integrate it into that access management system? And that's what we've done. So we've got a product out there today which has an access management system that integrates with quantum entropy. Whichever quantum entropy device that we have, we can integrate with many, many different forms. And today we're working with Dave as well as part of Quaid to do that exact method. The second part of it is, how do we now look at other technologies in the cyberspace? Look at predictive AI. How can we help accelerate predictive AI using quantum technologies? So we're looking at how we can use QRNG, so quantum random number generation, in that environment as well. So that's really been what our key focus has been around, is how do we take existing tech and enhance it? A third thing that we've been looking at working on is digital twins. So how do we take your environment as an organization today and create a synthetic digital replication of it? How can we understand what happens if we make a change to that system? How do we look at, for example, on certain systems, looking at the degradation of the system over time, and how can we look at using QRNG as a source to understand how that system changes over time? So these are the sorts of things that we're doing as part of SECQAI, integrating all of this different technology, trying to look at how we can combat not only today's threats, but quantum threats in the future. So underpinning all of the work that we're doing, we're looking at how we can use QRNG not only on the NIST-defined PQE algorithms, but also in other areas of cryptography as well. So looking at symmetric encryption, looking at venom ciphers as well. So that's the key focus for us. And we're using the technology that exists today, technology that we see coming in the future, to help take that into a business environment and help a CISO, help the security teams truly understand where this applies, how this applies, and where they can really deploy it. Are there any questions for us? No questions? Great. Well, thank you, everyone. Thank you for your time. It's been great. So cheers. Thank you.